Why does it push -1, then a sub? Oh, it's CXX frame handler. What is CXX frame handler? CXX frame handler. What is that? Is that exception handling? I'm a noob to all this stuff, so learning is one of the main goals. So what is CXX frame handler? CXX frame handler. Internal CRT function used by the CRT to handle structured exception frames. What is CRT? Core runtime? Takes 4 parameters. I need to learn how exceptions actually work. Exception record that is passed in possible catch statements. Dynamic information about the stack frame that is used to handle the exception. Context. Additional information. Okay. So we push -1, then we push CXX frame handler. And then we FS. What was FS again? That was the floating point stack. FS. No, FS is file segment. I did read about FS, but I can't remember what it was. what the fuck this guy's on about. The registers FS and GS are segment registers. What the fuck is a segment register? On Windows, FS is indeed for thread-specific storage. Okay, so FS is thread-specific storage. So it loads whatever FS is pointing to, and then it pushes that. And then it loads a pointer to that back into FS. Okay. And then we actually make the stack frame at this point. And I'm guessing at the end of this function, oh my god, this function is huge. At the end of the function, we just add 54. I need a way to like jump. Jump to end of function or something. Do I have that? Yeah, let's go preferences, key bindings. Move cursor to end of line, move cursor to end of view. Control end. Control end. No, that takes you right to the end of the fucking file. I just want to go to the end of the current function. Don't think it's possible. Eesh. Okay. Anyways, we sub 48. We sub 48, but at the end we add 54, was it? Uh, 48, so that's 1, 2, that's 3 more variables that we're actually popping off at the end. Which I suppose is those 3 things that we pushed here. 1, 2, 3. Okay, fair enough. So we do have to pop off the exception handling shit ourselves. I need to read about how exception handling works because it's kind of magic to me right now. Let's just call this the XX frame. Okay. And obviously I like to look at the assembly, but more often I just read the high level shit because it's way quicker and easier to understand. So I've done these 2 things. Let me read the file into var 2c8. That's 8. That's an entry. So I've already got a struct for this. It's called entry header. Honestly, I could just rename it to entry. Because I'm never gonna have just a regular entry. Okay, so we read the entry. I may as well just rename it. I know this is an entry because we're reading from something I've been doing. I've like looked into the code for already the other day. Well, I don't know where it seeks. So what does it do if it's 3344? Oh, and it has this big fucking switch case as well. Okay, gotcha. Nobody actually wrote the code this way. It was originally just a big switch case, but it's been optimized in a strange way. 3344 or 3347. Okay. So it reads it into EX35. That's the size. Right? was only reading 2. And then it seeks it to the end. How odd. What is EAX35 used for? Seemingly nothing. Wait, so it reads it in there and then does nothing with it? Huh? This is why this shit is hard. And takes so long. Okay. So let's have a look at what these things actually are. So this is basically a text file which contains some information about what this function is actually reading through, because it's reading it from a file. And this is kind of what the file contains. So it's reading from a 33333333. So one of these things. 3334 is a header. 33343. We don't have any of those. We do have a 3347, which is size 4. And apparently it's an MV timer base, but whatever the fuck that means. Oh. No, it's reading it into a field. Okay. So this is 3344. And this is entry 3334. And I mean, we can look up what they are. 3334 is a header. Okay. And it's just reading it. So this is a pointer to a header. So I may as well, I don't know how, I mean, I don't know how big it is. We could make a struct for this. Level header. I don't know how big it is. Could look it up. Let's do it. Let's look it up. We need Visual Studio. So here's like a little program I threw together that can just read shit out of places. And it's not good code. It's a lot of copy paste. But it's fine. So 3334. I'm gonna read it. I don't know how big it is though. How about we make this return and in 30 feet? Run that and see what it spits out. Three, 4 size equals size. What did I do? I'm so fucking zoned out right now. Three, 4 size equals 16. 3, 4 size equals 16. Okay, it's 16. They're all 16. See, the good thing about this code, rather than trying to debug the original code, which means I'd have to like play the game and load up a level and then breakpoint when it sets this, like when it gets to some point in code. It would be tricky to do, but having my own code that just simply loops through all the fucking files and grabs the entries and outputs what I need, it's actually secretly a lot fucking quicker. So we know it's 16. So what we can do is we can go in here and go that structure size 10. Because hex 10 is 16. Okay. We don't know what's really in it. We have no idea, but we can, whoops. We can modify this now to be a level header point. Perfect. And then I'm going to rename that to header. Alright, and 3344 is 3344. It's a random seed. 3344. And how big is it? 2. Okay, I believe it. And that is a int 16, so I can come in and change the tab. It already knows that it's an int 16. Perfect. Alright. Okay, this one gets read into G level plus 96C, which is 96A. It's read in here, and it's size 4, so it's an int. Good, and it automatically changed. Perfect. This 3347 is MV timer base, but I have no idea what that is. MV timer base or something. We got those. These make sense now. And then actually OXF doesn't actually run this code. OXF. Oh, it might not be a pointer. It might not be a pointer. Let's check. OXD. This is the switch. 80. 9 OXE default. Default just skips it. What the hell? Okay. So I'm confused, and what we do when we're confused is no, it jumps down here. Why? Oh, OXF. Hang on, what? It's not. Oh, it is OXF. Okay, OXF. OXF. Okay. OXF, which is 15. Okay, get the calculator out. 3334 plus OXF. 3343. So it's not 3334, it's 3343. So is demo file path? Demo file path. So it's not the header at all, but we will need that eventually anyway. Demo file path? Reads it into allocated bytes. EDX 18. Right, okay. This does get freed. Where does it get? Initialized. doesn't do much before it does that. Why haven't I named this function? Huh. Oh, maybe because it's too much random shit. Yeah, this function does a lot of stuff. I'm just gonna call it like init level or something. Always come down here, we run this. We'll call create level, which does this. But this is just resetting some app fields. Resets fields on the level, right? Yeah, all on the level, except for one on. Oh, it resets AP. Okay, well, I don't know what 3343 is and when that gets allocated. Guess we'll never know. Oh well. I mean, it's not in my. It's not actually in the game. 3343. Control F for it. Yeah, it's not actually in the game, so I can't actually breakpoint it and see what it does. Because it's not actually used, so I think I should just ignore it if it's. If it don't matter, we ignore it. So most likely this is not a header at all. It's a caster. So I made a mistake. I got confused again. When I look at OXF, in my brain, I think OF, which in C# means a float that is 0. But that doesn't make sense. I don't know why I keep reading it as that. It's OXF, which is 15. Okay. So this is not 33. I read this as EAX equals 0, but it's actually EAX equals 15. And that's not 3343. It's whatever. Oh, I had it here. 3334. It's 3343. 3343. Yeah, which I have written here. Okay. So that means the rest of this is actually wrong as well. Right? No. OX10 is still right. Yeah, I'm good. And OX13 is still right. Okay, and then we switch on it. which is the reason why we did the subtraction in the first place, is so we could switch on it. Most likely. I imagine this switch statement does jump above. Yeah. Yeah, so the reason why we subtract 0 is because every switch statement basically it has a range of values that it cares about. So let's say it cares about all the numbers from like 2 to 8 or something like that, right? That means we could do a jump table where we jump to like 2, 3, 4, 5, 6, 7, 8. But here's the jump table down here, and the jump table always starts at 0. So that's reason number 1 why you'd want to subtract before you do the switch. So if you had the numbers 2 to 8, you'd first subtract 2, and then you'd have a jump table with 0 to 6, or something like that. Yeah. But the other reason why you'd want to subtract 2 and make it start at 0 is because in order to do the switch, in order to do the jump into the jump table, you have to do a bounds check just before. So if it's less than 2 or greater than 8, you don't want to use the jump table because you're gonna use garbage memory. You're gonna be like looking at this memory down here or this memory up here, which is like absolute garbage. So you always do a bounds check before you do a jump, before you use a jump table. But there's this clever thing where instead of doing 2 if checks, if less than 2 and if greater than 8, you just treat the number as an unsigned int. And if you start at the index of 0, all you need to do is check above, because there's this thing called jump above, which is basically unsigned. Jumps, unsigned, comparison, and jump. And basically, the reason why that works is because, let's say you have the number in your switch statement or whatever, right? Let's say this EAX6 variable is like 1, but the minimum case is 2. When you do the subtract 2, you get -1, and because it's an unsigned comparison, jump above will basically -1 when it's unsigned is OXFFFFF, which is the biggest possible number. So OXFFFF unsigned is greater than 8 unsigned, or 6 unsigned, or whatever. So you can do a bounds check that's like if it's less than 0 or if it's greater than blah, with just a subtraction and a single jump. Anyway. So that's why they do it that way. It's smart. So, case 1 would be 3, 3, 3, 5. And what is 3, 3, 3, 5? Firstly, if we got any of them, we do. Apparently it's the name, so it's the name of the level. Okay. 3335, and I think I already wrote code for that. We grabbed them out. Yeah, these are the names. Cool. And that's, make sure that's a car star. Yep, it's a car star. Alright, case 3. Case 3 would be 3337. And it didn't show up. I have to put the comment all the way down here. Okay. 3337. I wonder what happens if I put it here instead. Oh, it does show up there. Okay, cool. 3337 is the palette. Oops. Three 3337 is the palette. And that actually makes sense. Yeah, frame palette. Okay. And yeah, I've already got it as the logical palette. Do something with a palette. Yeah, jeez. What's this one? 3338. Nice. Okay, so it's passing G level twice. I guess it's like a this call. Yeah, it's a this call. It's not a this call though. Look at that. It's popping ECX at the end and pushing it at the start. So it thinks it's a this call, but it's not a this call at all. It's just a CDEC call. And how do I know this? Because I spent like the last week figuring out how calling conventions work. Yeah, if this was a third call, it would do other shit. So no, this is a CDEC call, and it does not take an arg. It only takes 2 arguments. I mean, not much point fixing that, but like it's kind of cool to be able to see why that's the case. Okay. Okay, now it says it's taking the same thing twice. What the fuck? Pushing two things, ECX and EAX. Entry. Why does it still say it's a this call? It's not a this call, it's a CDAC call. I need to. CDAC call. There we go. So now it's correctly showing up as two parameters. So it's passing a G level and an entry. So we can change this to level. Very nice. Oh, it's doing weird power sum shit. This is 3338, by the way. Which I did comment, but it disappeared. I mean, do we have any of them? We do. It's item instances. Read item instances. I don't know if that's a good name for it, but we'll go with it for now. EAX is the app. Yeah, I have no idea what this is. Okay, so it's reading it into var 4. It's definitely a struct or something. Okay, so what we've got here is basically in ECX3, we have some amount of bytes. And basically we need to look at how it's getting used to determine what the heck it is. So the first thing we notice is we're grabbing a word out of the first 4 bytes, I guess. So maybe we have a word at the start, then it's like a struct with a word at the start. So this is a level. And we're setting field 44 to that. So field 44. It's probably the count. Would be my guess. Because then immediately, if the header project subversion is some bullshit, OXC8 is greater than OX2D. So this is like some random version check. And the power sum is not equal to so this is a hash check. Entry 2223. I think each entry has a hash. So ECX3 is the buffer. EX2 is probably some index into that. And we're multiplying by OX14. And we're adding 4. OX14 is 20 bytes. And it's freeing it at the end, so we're actually... So this is just a bar. I mean, I'm just gonna name both of these buff, because they're both the same, essentially. I mean... rig. Okay. I don't know about this shit. I mean, we could breakpoint and see what it's doing. Let's just see what else we're doing. Okay, so the next thing we do is we allocate count plus 1 times 24. This is... Yeah, these are basically, this is a struct with a length of 24, that's for sure. So this is some kind of count, like an item instance count. But it's doing +1, which is strange. But fine, okay, we always get one more than that. Count -1. This is like the item instances. I mean, we'll just call it item instance. And this is the struct size was 24. And we're going to call it an item instance. Sure. And this type is an item instance pointer. And we'll change the type of this as well. Item instance. As a pointer to that list. Why does it think that's a level? Oh, because it's getting set to arg1. But arg1 is set to null pointer. And then it's getting set to EAX10. It's just a word. This is the annoying thing. Basically, when this gets set to null pointer here, it actually becomes a new type. I don't know how to do that. I don't think it's possible. So I'm just going to change this to 32. Oh, that ruins everything though. I guess it doesn't matter. We just have to know that arg1 starts as the level, but then it becomes an int 16 down here. So it gets set to 0. And then it gets set to something. It gets set to the first field of this struct. So this is buff +4. Okay. So what we can kind of understand from this is this buffer is it starts off with 4 bytes, which is the count. Then it's got a list of EAX2, this is count. Then it's got a list of count OX14s. So we're adding OX14 here. So we could make a struct from that as well. So when we add 4, EBX2 is now pointing to a list of OX14 structs. Following, hopefully. This is 14, and this is item instance data. it's just an index. This is not a level. This is an N16. Also known as a short. The 48 is actually an N. I mean, it's more likely to be a word, but whatever. I think that's an optimization, but should be fine. Okay. All right, I'm gonna take a break. I'm gonna grab some dinner, and I'll be back very shortly. Okay. Bit hot. So I could start writing code for this. And just see what it does. EBX2. We're calling a function. And it takes 2 pointers. So we can actually input those 2 pointers. It takes an item instance as argument 1 and an item instance data as item 2. An instance. And an instance. Oh, it's just a okay. Yep. I mean, so we can instantly see that these are all. It's just a copy, direct copy. What game or software are you reverse engineering? I'm reverse engineering Multimedia Fusion 2 runtime. Which is essentially this old drag and drop kind of game making engine runtime. The end goal is basically oops. Right. Documents. This is gonna be loud, but whatever. It's not that loud. Basically, the end goal is to be able to re-implement this game. This is basically kind of what the engine is capable of. It's just like a 2D based kind of game. But it's all like drag and drop made, so all the code to actually play the game is mostly just data in files. So it's kind of, I mean, it should be less code to reverse engineer because a lot of the code is actually just written in data, but we'll see. I'm still in very early stages. And I'm really just learning as I go, so it's mainly just for learning. So when I see all of these fucking mobs, no, it's actually loading a word and then loading it into a field. So these are not, this is not a mem copy, because a mem copy would just go, it would use the full register. It wouldn't use like half of the register. So these are actual int16s. You'd think the compiler could optimize that, right? These 2 lines, or essentially these 4 instructions, could be just 2 instructions. It's copying a word and then it's copying a word at the next fucking offset. So why doesn't it just combine them? I guess that's like a really specific optimization to look for, and maybe compilers don't do that. But I don't think it's that specific, because it's this kind of thing you do all the time when you write code. Anyway. This was probably compiled by like a really old like VC++ from like 2002 or something. The right hand side is decompile. Yeah, it's basically they call it high level IL. It's essentially decomp. You can make it look like C, but I prefer it in high level IL because it just makes it a bit more compact and it's a bit better output, in my opinion. C has trouble representing a lot of things, whereas high level IL just looks nicer. Like, look at that. Look at all these fucking casts. Whereas in this, it just looks like that. So yeah, I'm mostly looking at the IL, but it's nice to kind of see both. Like, this output is the main reason why I bought this software. Because it would be a pain in the fucking ass to do it without. I don't know how people do it. People look at it in like graph form, and graph is kind of cool. Like, I could get used to this. Like, this is a big if. That's another if. But like, I don't know. Shit's hard. I can see this is an if, and then this is the nested if. And this is much more intuitive to me, because I just used to it. But yeah, welcome. Does anybody else stream decomp or reverse engineering on Twitch? I'm sure people do. Okay, so every single one of these fields is just a direct copy. I did learn some RE from guided hacking, but I'm still in tutorial of RE. What do the RE pros do to escape tutorial hell? Bald guy. I am still a noob, so I couldn't tell you. This is my second week doing RE. I'm reading this book. I'm reading a book called Reversing: Secrets to Reverse Engineering, which is an old book. It's from like 2005. But the funny thing is, it's from the exact era that this game that I'm reverse engineering is from. So it's like pretty relevant to what I'm doing. It talks about like Windows XP and shit, which is exactly like the era this game was made in. So yeah, I'm reading that book. I'm like 200 pages in. And it's like 600-page book. That's really good. You've probably heard of it, I think. Yeah, I'll show you. Reversing Secrets of Reverse Engineering. Yeah. It's like, it's on GitHub. And you can literally just grab the fucking PDF from GitHub. And this is where I grabbed it from. There it is. It's a really good book. I'm just reading through that. But like in terms of escaping tutorial hell, my advice is just, you know, pick a project and work on it. Like pick something you're interested in and you want to reverse engineer and just try to fucking do it. And learn as you go. You just gotta put in the hours. I Dota 2. Well, Dota 2 is like Source Engine. And Source Engine's got a lot of fucking leaked code already. Which is also good. Like having code that you can reference is really good. What's also famous for Linux? I'm pretty sure Source Engine is like cross-platform. The offsets were wrong. Yeah, like there'd be minor differences, but like just having something to kind of understand the names of stuff, like somebody, there's already been a lot of work done on what I'm doing, right? This guy wrote a complete Python runtime for Multimedia Fusion 2.5, I think. It says MMF2 here. But essentially, this is a full runtime written in Python, and I don't know if he used reverse engineering or if he did it a different way. Because the code is a bit, it's very different to the code that I'm looking at. It's structured very differently, and of course it's written in fucking Python and not C++. But it's useful to like grab his names. So like I found out, I basically grabbed all this, like these are what he called like all these things in this big enum. I just grabbed that and I was like, cool, now I kind of know what these things are. Like 3348 is mosaic image table, whatever the fuck that is. I'll start figuring that out at some point. What I'm trying to say is it's useful to have something to refer to just to get like, even if it's not perfectly, you know, if it's not the exact decomp of this engine, but it's got a lot of the same ideas as it. So it's kind of useful to refer to. Work and trial and error. Yeah. I started by running the game in a debugger and just finding interesting functions. And then what I did was I use Cheat Engine, and Cheat Engine has this feature where you can actually, probably debuggers, a lot of debuggers have this functionality, but you can replace the opcodes with nops, with like no ops. So I essentially just like went through, found some functions I was interested in, nopped some of them, and I was like, okay, when this function is nopped, the game stops rendering this part, like the HUD on the screen. And I'm like, cool, that function must be drawing the HUD. So just by knopping out different functions, I was able to kind of like figure out kind of a rough idea of what does what by what wasn't happening when I commented it out, essentially. So that was cool. And that helped me kind of start. And now I'm kind of just like doing it without a debugger. So what is this EDX3? This is not an item instance data. This is an N16. What? I hate that. Why? Why did they do that? Whatever. I don't care enough. So anyway, it sets field 0, 2, 4, 8, C, E, and 10. Zero, 2, 4, 8, C, E, and 10. It's actually more clear in this fucking view, to be honest. 4 and 8 are both D words, the rest are words. So yeah, it's just copying. This must be an index into that shorts count. Index, There's a kernel debugger for Cheat Engine. Wow. Do you run your kernel debugger in a virtual machine? I just started reading about that in my book, and it was talking about how like the different types of kernel debuggers. And there was this like soft ice one that like did it in this really hacky way with like a keyboard driver. But I assume everyone these days just uses a virtual machine. Test signing. I don't know what that means. reclass.net. What's that? Not Okay. Anyway. Almost done eating. So why is it doing this at the bottom? Oh. Okay, well these are all D words. 14, 18, 1C, 20. And these are all arg1s, which is instant. I kind of just have to add these manually. And these are all ints. Cool, so we've actually filled out the entire struct. There's 20. Yeah. It's always nice when they use every single field of a struct. That doesn't happen like very often. Wow, a fully initialized struct. Like there's almost always wasted space, like this one. I don't think it's gonna use this. You need to pay for a cert to make kernel software / drivers work. It's a test signing mode if you don't want to pay for servers. Some software don't let you run test signing mode. Huh. Yeah, I've never even considered that would even be a thing. Like, I didn't even know kernel debugging existed until like a few days ago when I started reading about it. I thought a fucking user mode debugger was just a debugger, right? I've never heard it being called a user mode debugger. But now I know. I'm learning so much shit, man. It's insane. But thanks, that's interesting. I wonder why it lets you debug it like that. Okay. I'll see you around Han So High. Thanks for the follow, by the way. So I'll see you some other time. Okay. So this is a key. Yeah, this is a key. This is an entry 2229 223F. And so is this. So if it's within the shorts count, So we get the key to index, and then we get the list. So ECX2 is something from this list. And that's an entry 2229223F. Which has an offset too, which we can fill in. And that's a word, I believe. No? Oh, because this is weird stuff. Why can't it tell that that's... I don't know. Like if I'm indexing into a list and it understands that that's what I'm doing, why does this avoid star then? When the type of this is... Oh, that's an entry star star. Yeah, that makes sense. So I do get an entry star when I index into it. That's not equal to 0, then we're setting field 12 to field 20 of that. Huh. All right, so what can we call this function now? Init item instance, I guess. Good enough. Where were we? We were in here. Okay. So OXD, what is that? 334 plus OXD. 334. Reading to 38. X, Y, 3, 0. 38 is where we read it into. Entry and offset. Why is it setting it to itself? Oh. This is EBP equals 0. Okay, that's never going to be 0, so we don't do that code anyway, so don't worry about that. Basically, all of these ifs are